Okay, so the other camera did not work. Having problems with it. Here we go. Everybody at home, you're going to have a blank periodic table. I apologize to you at home, but you need to print this yourself somehow, okay? Eventually, I'll ask you to turn this in. We're going to color on this table, so you have to print it. If you can't get one, come to school and I'll give you one. Other than that, I'm sorry that we're in this situation. Maybe you could digitally put this on a PowerPoint and then use the pen on the PowerPoint program to draw on it. You could definitely do that. Google Slides may also have that option. But here is a blank periodic table. And we're going to go over the notes, the Google Slides about the periodic table. So here we go. All right, so I'm literally viewing your slides, and let's get started. Not going to do it for me. All right. First things first, periodic table by group. These are things that we're going to need to know about the periodic table. The alkali metals, alkaline earth metals, transition metals, etc. We're going to go through them right now, and I'm going to speak quickly. All right, first thing you need to do on your table is draw some stairs right here. Where do those stairs go? They start right under boron, and then you're just going to draw a perfect set of stairs. Okay? So the first thing we do is we're drawing a pair of stairs on our periodic table. So if you're at home, boron is right here. And then you're going to draw some stairs like this. People in here are going to have to go kind of quick to keep up with me. All right? Now, everything on this side of the stairs, just these few elements over here, these are called the non-metals. All right? Just these elements up here. You don't have to color them in right now. I'm just showing you. All these elements to the right of the stairs are non-metals. And then everything else on the periodic table, in some way, shape, or form, is considered to be a metal. So the periodic table, first of all, is divided by these stairs into metals and non-metals. And the large sum of the periodic table, we consider those elements to be metals, okay? So, properties of metals. Things that are metal. This is notes. These are things you need to write down. Things that are metal are malleable, ductile. They conduct electricity, and they're usually lustrous and shiny. This spring is a really good example of something that's metal. You can see the spring right here. It's obviously bendable. Okay? It's lustrous, it's shiny. Okay? And I think we all understand by the time we're in high school that metals conduct electricity. I think we already all understand that metals conduct electricity. Okay? Malleable means if you hit it with a hammer, it will just dent instead of break. And this word you may not be familiar with, ductile. Ductile means that metals can be spun into a wire or pulled into a wire, however you want to think about that. That's what it means to be ductile. All right. That's what it means to be ductile. All right? Now, we'll talk about metallic bonding later in the semester, but metals, when they bond with each other, undergo metallic bonding. All right. Group number one. This group right here. Group number one is called the alkali metals. The alkali metals. So on your periodic table, you're going to color this, and you're going to label this as the alkali metals. The alkali metals are very, very reactive. Very, very reactive. They're so reactive you can't even get them wet. If you get them wet, they will react with even the water, okay? So the alkali metals are very, very reactive. All right, it's going to be a loud noise here. So there we go. That's me turning the gas on in the room. When I turn the propane gas on. So the alkali metals are very, very reactive. If we look at the alkali metals from top to bottom, we're looking at hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, right? We saw sodium get wet and explode in a pond earlier, right? So the alkali metals, here's some other traits about them. They're very soft. They're so soft you can cut most of them with a butter knife. It's a metal that you could cut with a butter knife. And they're so reactive that when we ship them, we have to ship them or store them in oil. You can buy sodium online, no problem. Okay? And they'll ship it to you in a little container. And in the little container will be some sodium, and it will be swimming in oil. That way it can't get wet. Do you think you could take alkali metals with you on a plane? No. It's something that will explode when it just gets wet. But alkali metals are very dangerous. All right. Here's the next group, group 2 on the periodic table. Group 2 on the periodic table. These are called the alkaline earth metals. Shade this group in right here, the alkaline earth metals. These are the metals of the earth. Okay? The batteries, when I was a kid, the good batteries were made from the alkaline earth metals. And if you look on Duracell batteries right now, you'll see it says alkaline. Alkaline. I don't know why I'm getting the smell. Can you guys smell the propane in here? I don't know why that is. The flame's burning perfectly. We'll see. It won't be burning for much longer. People at home have got a Bunsen burner going, and I'll let you see it right here. We're getting ready to use this in just a second. All right? So, the alkaline earth metals, they are very, very reactive. They're not as reactive as these, but they're still very reactive. If we think about what's in here, we have beryllium, magnesium, calcium, right? Strontium's in this group. These things are reactive. They're in fireworks. They're in batteries. They're very reactive. Oh, now I'll see what the problem is. Hang on, everybody. The gas is on in the room. All right, people at home. At some point this summer, someone had turned on a gas nozzle in the back of the room, and we were smelling it, so we had to pause the video real quick. I've got everything fixed right now. We're going to light it back up. All right. So, we were talking about the alkaline earth metals, and the reason I have this lighter is because right here, I've got an alkaline earth metal. This is in period 3, group 2 on the periodic table. I've got some magnesium. Magnesium is very reactive. And it's going to be just out of your picture at home. And I'm going to put some magnesium on this flame. Okay? And to do this, I'm going to wear a mask. I'm going to use this little parasol. Okay. I look like someone that is seriously worried about corona right now, don't I? All right. Here we go. This is magnesium, an alkaline earth metal. I'm going to show you how reactive it is. I told you alkaline earth metals are in fireworks, right? What firework is this in? Yeah, they're in sparklers. That's exactly right. So, does that help a little bit with the smell of the propane? All right, because I'm going to have to cut it off because we won't be able to see the board. All right, so there's our alkaline earth metals. Boom. In the middle of your table, in the middle, those are called the transition metals, okay? In the middle of the table now. What you really should do is go across the middle of your table and slide all the way up under the stairs. So if you're shading in the transition metals, you're going to come all the way up under the stairs, okay, and shade this whole area. The skip from this tall row to these tall rows, that's the transition we're talking about. And these in the middle are called the transition metals. Now, the transition metals are metals that you are used to hearing about, or metals that you are used to working with, okay? These are the familiar names for you, the transition metals. All right? If you look in there, here, you're going to see iron and copper and gold and these really popular metals. The transition metals are most widely used by humans in iron and nickel and copper, gold, silver. All those things are in there, okay? All of the elements that we make steel with are in the transition elements. Iron and cobalt, titanium, vanadium, chromium, those are transition metals, okay? And when you take those transition metals and you mix them up together, you can make alloys like bronze and brass. And humans have been doing this for a very long time. That's why the transition metals are the most widely used by humans. They're so popular, though, you don't even think about it. Take a look at this. Whose helmet's this? You're right, everybody. You're right. It's the Pittsburgh Steelers, they all said. It even says Steelers right here. Okay. Oh, did you? All right, I didn't hear you. Okay. So these diamonds on the Steelers helmet are from the periodic table. It's iron, coal scrap, and steel. And the blue is for steel because of cobalt. Cobalt is a bluish steel. And if I didn't have my mask on, I could give you my best version of the blue steel. And you may not know what that means. That's a silly joke. But the periodic table is literally posted right here on the side of the Pittsburgh Steelers helmet. Can you come up with another football team and their helmet is from the periodic table?
I wish you said the Saints.
Well, no, it wouldn't be the Saints. How about this? How about San Francisco? What color is their helmet? It's gold. I wonder why their helmet's gold. What's the name of the team? San Francisco 49ers. The San Francisco Minor 49ers. That's what they're named after. The 1849 gold rush. That's why their helmet's gold. So here's the periodic table again, the transition metals in football. All right. Next, all of the elements that are touching the stairs are sort of splitting themselves between being non-metals and metals, right? So you want to shade in every element that touches the stairs except for aluminum and astatine, okay? Shade those in. They are called, I know it's way down here, metalloids, which means they're metal-ish, right? They're called metalloids. So everybody touching the stairs here is considered a metalloid. We use metalloids because sometimes they can act like a metal and sometimes they can act like a non-metal. Their behavior is environmentally dependent, and the most popular one that I can come up with is silicon. Silicon's used in computer chips, and we're using the property of silicon for its ability to sometimes conduct electricity, and then under other conditions not conduct electricity. Okay? Silicon Valley, where Google and the other big tech companies are, is named for silicon on the periodic table, and it's used because it's a metalloid. All right? Metalloids. Metalloids, and you don't have to write this down because I just told you what it was. They're semiconductors. They only conduct electricity under certain conditions, okay? All right. Now, down here on the bottom of your periodic table, you can shade in all of those. There's 28 on our table. There's 28 total boxes down here on the bottom. And they're called the inner transition metals. And they're not as easy to use or as popularly used as the regular transition metals, and because they have some special traits. All right. And if you look down there, you won't recognize a lot of the names, especially in the top row. You'll recognize some heavy hitters down here in the bottom row. The inner transition metals have some special uses, and one of the special uses for the inner transition metals is that they're very sensitive to light. And we use them to pick up photons of light, or we use them in sensors. Down here in the bottom of the inner transition metal, there's even a synthetic element, number 95, called americium, that is so sensitive to photons that we use it in smoke detectors. Okay? It's a man-made element that we actually use in smoke detectors. Okay? This is what the periodic table really looks like. This is an important slide. Take a look at this. This is really what the periodic table looks like. And we take these and we cut them out and we put them at the bottom. That's why they're called the inner transition metals. They're really in between here and here. So all of these guys in the middle, they're transition metals, right? And these are the inner transition metals. So we always draw the periodic table like this with them down here so it can fit on the poster. That's why we do it. All right. Group 7 is called the halogens. All right? Many of you know that the first really bright light bulbs we had, the really bright headlights, from when I was a teenager, those were halogen light bulbs. They got very, very hot, but they were pretty bright. They're not as bright as the absolutely blinding headlights that some of you buy for your cars and then angle incorrectly where you're shooting them right into people's faces where they can't see. But they make very bright lights, okay? But a more important use of these halogens from group 7, so we're talking about fluorine, chlorine, bromine, iodine, astatine, right? We're going down that list. These guys are halogens. The real word for halogen is called salt maker. Halogens form salts when bonding ionically with a metal. Okay? So here's a good example. Here's chlorine, right? Excuse me. Here's chlorine, right? Here's sodium. Sodium and chlorine come together to make salt, right? Sodium chloride. Well, one of these guys with any of these people are salts. Calcium fluoride, calcium bromide, magnesium iodide, sodium fluoride. Those are all salts. So halogens are called the salt makers. Okay? All right, group 8. These are the noble gases. The noble gases. The noble gases do not bond with other elements. They keep to themselves like nobility. That's when we call them the noble gases. Okay, the noble gases. You remember from looking at the Mendeleev lab that we just did from the game board from earlier today? All of these are full, right? This one had 2 electrons in its inner shell, then 8, 8, 8, 8, right? So they can't accept any more electrons. That's why they stay to themselves and they don't associate with other atoms. That's why we call them the noble gases. You can take helium and fill a balloon with it and try to set it on fire. You'll never get an explosion. Same with neon and argon, etc. They're inert. A word for the noble gases is inert. We use them in windows for insulation, and even in shock absorbers on fancy motorcycles. We don't use them on dirt bikes. And then the other groups, this leaves us just a couple other groups. They're just named by the elements at the top. So for example, this is the boron group, the carbon group, the nitrogen group, and the oxygen group. Okay? And that's it. That's what they're called. All right? And one of the last things I want to really mention are that the elements that you see on the periodic table that are in white, they're called synthetic because they're man-made. And that means we've never found them naturally in nature. It doesn't mean they're rare. It means that the only examples of these atoms we've ever seen, we produced in a laboratory. Okay? Now, it doesn't mean that they're not important. Because if you look down here, there's a lot of them that are very important. Like this would be uranium. Right? Number 92 is uranium. Like, it naturally exists. But look two over from uranium. You got plutonium and americium. I know that you've heard of plutonium being used, right? Americium, I just told you, was used in smoke detectors and in other type of gas and fume and light detectors. And plutonium is used in nuclear energy. So the synthetic metals can be very useful, but many of them kind of aren't. And the last thing I'm going to tell you about the periodic table is many of the elements are radioactive. All right? And that means that they fall apart and they give off particles. However, the radioactive elements are not in any way labeled on the periodic table. And I'll show you what I mean. If you look over here at the periodic table and you see, I'm not too awful bad. We have black here. Black means it's a solid at room temperature. We have blue. Blue means it's a liquid at room temperature. And we have red, and red means it's a gas at room temperature. We have white, that means that it's man-made, okay? So it wouldn't be anything at room temperature because it doesn't really exist, right? And then there's no color or particular pattern or particular place that shows you if an element is radioactive. There's no indicator of that. A lot of students, when they come in, believe that the ones in white are the radioactive elements because they see plutonium. But that's not really how it works.